Okay, so I have sigma of I squared minus 3i plus 2i going from 1 to n. If you look at this thing, I don't have any formula of this guy, but we know the properties of sigma or summation tells me that I can separate each term. If there are sums of different things, I can separate them. So I can write sum of I squared minus integral of 3i plus sum of 2. I goes from 1 to n, 1 to n, and 1 to n. And then there is this rule of sum of the constant multiple always can come out from the sigma. So this is I squared, I going from 1 to n minus 3 sigma I going from 1 to n plus sigma of constant. So sigma of constant is something very interesting because while you have 2 and you're adding it to itself n times, obviously that would give me 2n. The second term here, it has a -3 to multiply that, but I know that sums of sigma i's, I going from 1 to n, is n plus 1 over 2. So here I just put n plus 1 over 2. And for sigma I squared, the formula is something that you have to keep in mind. This is n times n plus 1 times 2n plus 1 over 6. And that will give me n plus 1, 2n plus 1 over 6. Okay? And that's it. So you can multiply, you can simplify that and write it as sums of powers of n cubed, n squared, n, and then some constant. So here will be some multiples, but I won't do that here. Just leave it for you to do that. Okay, here, there is two things different here. First thing is that, well, I have to first turn this thing into sums of i's or I squares and so on. Well, that's easy. Just I will do I goes from 5 to 20, I squared plus 2i. And then use the property and separate them. But I is going from 5 to 20. I have a formula of I and I squared if I go from 1 to any number n. Here it goes from 5 to n. So in other words, I'm going to have 5, 6, 7, 8 up to 20. But the formula I know is when I start from 1. So in other words, I'm missing 1, 2, 3, and 4 here. So what if I change the sum to start from 1 to 20, but then I have added these 4 terms there, or maybe I'm talking about the second one, but that's the same thing. So I'm going from 1 to 20, but I have added those 4 terms. Now I have to subtract those 4 terms. Okay? That will give you exactly the same thing as this one. And for the first one is also the same thing. So I have added 4 first terms. Now I have to subtract 4 first terms. And then there's a summation there. Now, look, all the terms starting from 1 and going up to some number, n, it's either 20 or 4. And I can use these formulas, these 2 formulas here, and go ahead and write that down. So sums of I squared from 1 to 20, look at this formula. 20 is plus, it's in instead of n, I have 20. So the formula, which is for general n, now I can plug in 20 into n. So I will get 20 times 20 plus 1 times 2 times 20 plus 1 over 6 minus the second term. The n in the second term is 4, so I will use that same formula. 4 plus 1, 2 times 4 plus 1 over 6 plus 2 times sums of n i's. So going from 1 to any number n, in this case n is 20, is going to be n 20 times n plus 1, 20 plus 1 over 2 minus, this is from 1 to 4 of I, so it will be n, which is 4 plus 1 over 2. You can simplify that number and get one exact number there. The last example here, you look at this guy and say that, oh, okay, these are not powers of x, powers of I, and I have 1 over I minus 1 over I plus 1. So if you don't have any of those formats that we have seen so far, and this is not a geometric series, then let's just open this up and just get rid of that sum notation, see how this works. So if I is 1, I will get 1 over 1, so I 1 minus 1 over 1 plus 1, which is 2. If I is 2, this will be 1 over 2 minus 1 over 3. If I is 3, and this will continue up to when I is 300, which is 1 over, well, let me just write one more term maybe. I will go I to 299, which is 1 over 299 minus 1 over 300, plus when I is 300, this is 1 over 300 minus 1 over 301. Okay, so I'm going to deal with some like that, but what I notice is that the second term of each one of these elements in the sequence is negative of the first term of the next element. So here, negative 1 over 2, and this one is 1 over 2, so they will cancel each other. I mean, vanish, that piece will vanish, and this will vanish with that. This will vanish with the next one, and everything will vanish. This one will vanish, the one which will appear before. Negative 1 over 300 will disappear with 1 over 300 there, and the only thing will remain is the first term of the first element of that sequence, plus the second term of the last element. So it will be negative 1 over 301. So it's 1 minus 1, 301. And that will give me 301 minus 1, 301, which is 300 over 301. And that is what we have for some of these examples that you see here.